Hello and welcome to this short tutorial on how to combine Wonderland Engine with almost every web API out there. Today we're going to have a look and see how we can integrate the Sketchfab API with a Wonderland Engine based WebXR app. So in this case, I am going to go ahead and start by creating a new project. In this case, I'm going to call it Sketchfab API. And I'm going to use the VR scene so that VR is set up out of the box. So we have our default scene here, and our goal will be to just make a search on the PlayFab API and then retrieve all the images for that search results. So PlayFab will give us a set of models that map to our search, and we will then proceed to download the thumbnails to display them in our VR application. We might add a point and click later on to then be able to pick individual models, but for this tutorial we are going to focus on how we can make a request and how we can then influence the Wonderland scene to basically display the results of this request. Alright, so the first thing we're going to do is briefly have a look at how this Sketchfab API looks like. And if you're trying to use any other API, keep in mind it's pretty much the same thing. Sometimes you require authentication to use the API, but read-only APIs are usually free of authentication, so they're especially easy to use. If we scroll to the very bottom of the Sketchfab page, then we will find the developers and API link in the ecosystem. From here, we can find the data API and just click on REST API or view the full documentation here. This will give us a automatically generated Swagger UI generation, and it already hints at how to make authenticated requests. And you would need to set an authentication header, but in this case, we're going to skip that step since we know that we're only going to query the data and not try to make any changes or require logins. Hence, for us, it is probably sufficient to just look through the following resources here. And we will need one particular, that is search, to do actual search. So let's get started with the search part. We're just going to look for models. This is basically an example of how to make the request. And this is an example of what kind of results we can expect to get back. And we can even here, which is very, very nice, just try it out, for example. Let's add a tree, for example. Very basic request. And then just try it out. And what we get back from this request URL, where you see the request query parameter is just added in the end of the URL. We receive the following kind of results back. We have pagination. That means if we have more than a certain amount of requests, in this case 24, then we will need to call this URL to view the next page of requests. But the most important part of this is the results object property. And that gives us an array of objects that contain a URI to the model, the name of the model, and various other data that we might be interested in. In this case are actually even thumbnails for the model, which is great, but they are not to be confused with the thumbnails down here for the user. So what we're going to do now is we will translate this into JavaScript code, what we just did, clicking on this button basically. And for that, we will require this request URL. So let's start by creating a new component. And we will do that by opening the JS folder, right-click, new JavaScript component, and we will make this Sketchfab search. And if we click create, it will create Sketchfab search.js. If we double-click that, it will open whatever we configured Windows to open JavaScript files with. If you receive an error from like some JavaScript runtime, that means you need to go to the Windows Explorer. You can easily do that by right-clicking on the file and clicking on Show in Folder. And then you can right-click and select Open With. And then make sure to always open with whatever you chose, whether it is Atom or VS Code. In my case, it is Vim. So with my Vim open, I can now create the script. And we'll just start by making sure we remove all the functions we don't need. Init for us is not important, and we're also only going to do the search once for now. So we'll remove update, and start is great. We can, for example, change the console log here to be starting search with parameter, and then use this search text as the search. Now search text does not exist yet. We will go ahead and add that here as a parameter to replace param. And obviously we want to search for text, so we'll remove the float type and use string instead, which defines a text. For default, we're just going to use some random text. In this case, we're just going to use the same tree that we had before. If we save this file, we can switch back to Wonderland Engine and make sure to add this somewhere. In this case, I'm going to create a new object, add empty, and this empty object will be our search root to display the search results underneath. If we move this higher up in the air, we can later make sure that all our results are displayed somewhere around this spot. But now we want to add the script we just created. And we do that by selecting Add Component and then finding Sketchfab Search at the end of our list. If we open Sketchfab Search, we already see that search text has an automatically generated field, and we can put in anything we want here. We can, for example, say warrior instead. And then we might later find that Sketchfab will give us results for the warrior. Now we will actually have to do the request, the search request. So what we're going to do is we're going to use fetch, and fetch is a totally standard way of making requests in the browser. So this is not Wonderland Engine specific. This will be exactly how you would do it on any web page. So if we fetch, we need to give it the URL, and we find this URL over on the Sketchfab page we had before. We can just mark and copy it, and then we add this URL here. Make sure it's actually a string. And now it would already make the request. But we want the result of the request. So we need to use .then for the result. And then in this case, we're going to use an arrow notation function because it's very simple and it allows us to access the scope outside of this function. And that looks as follows. And since fetch returns us an arbitrary binary data result, we need to make sure that we tell it that it's going to be JSON. So we just do our JSON and return the result to then be collected by the next handler of the promise. And in this case, R is just a JSON object like we got here in the response. That means we have the full control over this results kind of property. And so we can do things like for const model of r.results. Then let's just console log the name for now. We can see that we are iterating over the results array. That is this kind of object, and this object has the property name. That is exactly what we're printing now. And we should see first trees and foliage. And then later on, we should see a second object. Here's a second, that's just called tree. And with that, a couple of more. Now let's see if this already works. If we write this, and then switch to Wonderland Engine, we can now just go ahead and click the green button at the top, which will package on launch our project in the browser. We can also just hit F5, and later on, we only need to click package to make sure that it refreshes the browser for us. So now let's click the green button and see what happens. It packages really, really quickly, and then it opens the browser for us already. We can make sure to have the console open I did that with Control-Shift-C. For Mac, it will probably be Command-Shift-C. And if we look into the console, we see that the console log already prints all the Sketchfab results. So tree and foliage, trees of Paris, nice. And this tree is growing. So we get a lot of interesting results here. But obviously none of that is showing up in our viewport yet. And if we're in VR, then we'll not have access to the console. So what would that help us? So let's go ahead and just display some values there. And we'll do that by just generating objects for every search result and then using a text component to show the result in 3D. So instead of the console log, we're just gonna put the name into a local variable and then go ahead and say this.object, which is the object that this component is attached to. Add component text, and add the properties for this new component, which is going to be text name, and finally material. And well, where does this material come from? We will need to configure this material in the editor, and that's why we're just for now going to say this.text material, and then add a new parameter, text material, and make the type material. There's no default for materials, it's always null, so we need to define this in the editor in a moment. If we go to the editor, we will find that automatically it already updated and now shows a drop-down for the text material. If we select none here, we can select the default font material to use a default material for the font. We can even change the color and some other properties like outlines, but for now we're just going to keep it simple and leave it like that. If we save, we will now need to make sure we repackage, that is Command-Shift-P or Control-Shift-P. And then the browser will automatically reload for us with the updated result, and if we turn, we see that we have a bunch of scrambled text at the top here. And if we teleport around a bit, we can actually look at it and see that, well, it's definitely not what we wanted, but it's getting pretty close. Let's do one quick thing, because if we reload here, we'll see that it'll always reset our view, and that is rather inconvenient. So let's go to the editor and move this Sketchfab results object back to where we can see it by default. If we save and package with Control-Shift-P, then we'll see the browser will update, and per default we already see the results. Nice, because this means that especially if you have two screens or a nice wide screen, you can now split screen with the browser on the right and the text editor on the left. So that means if I make a change to the script here, like for example in this case I want every text to have its independent position. I will do this in a second, and then whenever I save, it will automatically reload the browser for me with the new script running. So let's add a child object for every result. And what I did here is to say, I used a scene to add a new object, that's like spawning an object, and its parent is going to be this object. So its local space is always going to be relative to our parent search results object. I can now, instead of adding the component to this object, add this component to the child. And after adding the component to the child, we see it looks exactly the same. But if we move the child by a little bit every time we add a new result, we should get a nicely distributed kind of result in our browser. So every time I add a component, then increase the Y value by 10 centimeters. So what I'm doing here is every time that I added one of these components, I will decrement, so move downwards on the Y-axis. and then translate each of the child objects by a little bit more after each result. And if we save this, then the browser will reload to show our wonderful search results in a vertical list. And in this case, we can see trees and foliage, trees of Paris, and so on, just as we had before in the console. Now I continuously keep the console open such that we can see in case we make an error. So far, no errors are happening. There are some warnings, but those warnings are fine. Otherwise, now as a next step, let's see if we can add basically an image to every one of these. And for that, we'll add a plane. And that plane is a mesh. So let's add a plane mesh here, plane mesh. That's going to be a parameter of type mesh. If we save, we can again make sure that we can configure this in the editor on the search root object. And we find plane mesh currently configured as none, and we'll just set that to primitive plane. We'll also need a new material for the plane, and that's going to be a flat textured material. So let's add plane material and make the type material. Now when we go and set the plane material, we will see, okay, maybe we need to add a new material here. So let's go to Views, Resources, and this is all the resources currently in your Wonderland Engine project. So switching to materials, we'll see a list of various materials that were added by default. But we'll just go ahead and copy one of these, for example, green, and duplicate it. Right-click, duplicate, brings us to green down here. And we'll make this textured plane material. And we want this textured plane material to be flat, opaque, textured. Okay, we can drag and drop this into the plane material slot in our Sketchfab search. And then we can configure this material to, for example, have the default font texture, because at the moment we don't actually know which texture is going to be. We're going to be downloading the texture from Sketchfab and then setting it here. But for now, we're just going to add a placeholder to see if the material updates correctly, and it looks fine, it looks great. So now we can just close this up again, save the project package, because we changed component properties, and those need to be reflected in the bin file. And then make sure we spawn a textured plane every time we create one of these text components. And we're just going to add this as another child. So we call this plane. And child that to our text. That means that we don't have to keep track of how the plane is relative to every new created object, but only how it is relative to the text, which means it's the same for every of these planes that we spawn. And we want this to render as a plane, so let's add a mesh component. And the mesh component will have the plane mesh as a material, as a mesh, and the material will be our plane material. If we write this, we will see that the browser already updated with a very ugly kind of looking default texture here. Like we predicted, it's not going to be exactly what we want. But we also see that the planes kind of start in the middle here. So we're going to move those down and also scale them a little bit, because in my opinion, they're probably a little bit large. Also, I just noticed we made a mistake. C needs to be plane here because we want to be able to modify the plane object and then have the plane move along with it. And if we then scale the plane, maybe by 1/4, and translate it downwards, then save that, we will see the planes are now way smaller and they begin exactly underneath the text. But text seems kind of like still too far to the right. So let's move the plane to the right, and then we can make sure to give the text enough space in between so that the plane is always non-overlapping anything else. So on the x-axis, we will also move by 0.5. And then finally make sure we increase the separation a lot more. And once we save that, the browser will update and we will see that everything has sufficient spacing. Now, obviously, we'll see that, okay, these search results somehow drop down into the floor. But we'll worry about that in a second, because that kind of layouting is fairly, let's say, that's basic programming, right? So we'll have that fixed in the end. For now, we're gonna focus on the Wonderland Engine specific parts, and that is how to load this texture. So let's see that we load a texture. And we will do that after specifying the material here. So we will make sure that we have a new material. And because all the materials are kind of one single instance, we need to make sure that if we change a material, we always clone it first. Otherwise, we will change everything that is using the same material. We do that by just adding a new variable mat and cloning the plane material. Now, if we use mat instead of plane material here, we will always have its own individual instance. So something that will always be changeable without changing anything else. And now we go ahead and change it. And what we want to change is obviously update the texture. So for this, Wonderland Engine has a very convenient function, and we can do wl.texture.load, and then we specify the URL of the texture to load. So let's check where that URL is that we need. If we go back to our documentation of the Sketchfab API, we will find that we have a thumbnails property here. And thumbnails contains a property called images. And images is an array of images of different sizes. Now, we have fairly small little rectangles here. So we definitely do not need like a full-sized image with like full HD kind of resolution. And that would also like be too much for the Oculus Quest to handle if we have a lot of results. So let's move downwards a bit, and here we find one with like 256 pixels width. That's actually kind of nice. So what we'll do is we'll just expect Sketchfab to return the same results. Maybe that's not the right way to do it. You probably search through the array and try to find the one with the correct width. But we'll just expect it to always be the 0, 1, 2, third element. Okay, so going back to our code, we will go ahead and find the URL, which is model thumbnails images, and then the third image, which is the fourth image at index 3. So this is the URL, and once it's loaded, we want to apply it to our material. This again returns a promise, which means with .then we can get the texture. And then apply this texture to mat. And we don't know which property here to use, so we go back to the editor, open the material, and we see it's called flat texture. Sure. And it's exactly the same here in the code. So we go and put in flat texture and assign texture here. If we save this, the browser will reload for us, and now we see something broke. Cannot read properties of undefined, reading load. That is because I made a small mistake. It's not called WL texture, it's called WL textures. So let's save this. And then we'll see, okay, we kind of have weird undefined errors here. So let's see what's going on. In this case, it's printing the errors here because it looks like we're specifying the URL incorrectly. So let's go ahead and find the code that is running this. If we switch to sources, we can find our Sketchfab API bundle. That is the bundle that Wonderland Editor creates for us with our scripts in it. We move to the very bottom, then we will find, hey, this is our Sketchfab search script. So let's see if we can debug this and then figure out what kind of error is happening here with the textures code. You'll find sometimes that the offsets are incorrect. That is a small bug with the current version. But if we roughly find the right place, in this case, it's one line above, we can now reload the page. And once this code is executed, it will stop here and we can continue to investigate what's happening. So we can see here, the thumbnails has 5 images. That's great. Well, the images obviously themselves aren't URLs, so typical, very easy to fix mistake. Images itself returns an object, and the object in this case has a property URL, and that's the actual thing we want to pass to the load function. So let's remove our breakpoint, we won't need it anymore, and then go ahead in the code and add .url to the end. If we save, the browser will reload for us, and if we check the console, we will see, okay, this is somehow not same origin, defaulted to same origin by Quep. What the hell? This is a very, very cryptic error, right? But it is very simple if you know what this is about. Because Wonderland Engine uses WebAssembly threads, it passes certain headers to the HTTP requests that enforce some extra security measures to your website. And in this case, we can just disable the thread support and make sure that these work. Unfortunately, because the WebAssembly threads and required shared array buffer pose certain risks of Spectre exploitation inside the browser, these extra security measures are important. But the thread support itself is not totally necessary, as performance is still really, really great without, barely not noticeably worse. So let's go ahead and find the required properties in the project settings. So we go to View Project Settings, and then that'll open the Project Settings tab for us. And here under Editor, we will find Server Corp. And if we hover over here, so this has 2 settings, the Require Corp and the Set to Unsave None. So let's go Unsave None. And then save this, package this, and make sure we reload our browser. And this will now give us a different error, which is wonderful. This is now about the data being cross-origin data, which is great because that means the data actually arrived in the browser, but currently it's just not allowed to be uploaded to the GPU yet. This is fairly easy to fix because we can go ahead and check the JavaScript API for Wonderland Engine here and find the textures.load function. So if we go ahead and find load, then we have textures.load here. And we see it has its second parameter called cross-origin. In this case, we can specify the cross-origin flag as a second parameter to load. So we just go ahead and specify no course for the cross-origin parameter. And if we save that and then go back to our browser, we will see that this actually now finally loads the images correctly. Okay, very, very beautiful. This is getting somewhere. We already have search results displayed, we have images as planes, and now let's go ahead and fix this weird layout issue. And just whenever we hit 3 or 4 images in a row, we'll just wrap to the next kind of row. And by doing that, we create a grid. So let's go ahead. And instead of using Y here, we are just going to use a counter I and increase I with every iteration. And now we're going to compute Y and X from this counter. And we are going to do that by finding out the row first. That is going to be I divided by 3, but make sure we floor that as 2, for example, should result in row 0. And the column will be the I basically, but modulo 3. And now y will just be what we had before, O.6 times the row, and x should be something around O.5, or let's give it like a little bit of space, O.6 times the column. Finally, we also need to move by x, and this should already give us a grid. And if we go here, we see, yep, it works, but we inverted y in trying to fix this. So let's go ahead and use -06 here. And we see we now have a wonderful, fully functioning grid. And the wonderful thing is with Wonderland Engine, this already works in VR, and we'll see all of these results in VR already. We also notice though, like some minor details, the spacing is definitely not enough. The text is just too long for most of these. Let's scale down the text a bit. We can do this by scaling down the text by half, but this also will scale down the child. So let's make sure that we scale up the plane by 2. And then have a look at the result. This also messed with our offsets, so let's go ahead and scale up the offsets again as well. And we see this is a way finer kind of UI with more space to it and smaller text, as well as non-overlapping anywhere else. There's one last issue where the final image is not being loaded, and that is because this one probably doesn't actually have 4 thumbnails. So this 3 that we have here didn't actually work. So let's, I guess, fix this after all. And that is index should be here. The thumbnails basically will go through and search and for every image we will check the width, whether it's smaller or equal to 256, and if it is, then we will have the index, and then we will use this index for the image. So let's save that, and it will automatically reload the browser for us, and you will see it actually even loads way more images now because it just stopped at the first image that it didn't load properly. This is really, really awesome. That means we can just increase the columns, and let's make those configurable, because who knows, maybe your artist in the team is going to use this component to pull down everything he wants, and he might need some interesting variables to configure. Because it's so easy to set up with Wonderland Engine, let's just add column count here, change the type to int, save this, and then make sure that instead of the 3 down here, we use column count. Also, because ints can have a default, let's make it default 3, like we had before. And if we go to the editor and find our component, we will see that in the top it added a column count. Let's make the count 6. Save package, and we can switch to the browser and see that this is now a full kind of Sketchfab search results grid, and voila. This is how you use APIs in Wonderland Engine. This is fully compatible with VR, so if you test this scene in the Oculus Quest, for example, you will see it'll just work out of the box. And finally, if you have any questions, feel free to hop on the Wonderland Engine Discord. We also just recently launched a questions forum that you'll find on answers.wonderlandengine.com.